that we've done quadratic formula, we're going to talk about some equations that are not quadratic, but I like to call them quadratic type because they can be treated like a quadratic equation. And once you see the way in, it's pretty much solved the same way.
Once you see the way in, there's no...
Yeah.
Of course.
Okay, so for example, we'll start off with an easier one. Let's say I have x to the 4 minus 6x squared plus, let's say, 4 equal to 0. Okay? You could try to factor it. It's not going to help, though. But what we mean by quadratic type is that this exponent is always what?
Half of that.
Yes. It's half of the leading exponent. So half of leading exponent. And as long as that condition is met, as long as this is half of that one, you can always treat it like a quadratic equation. But first you have to rewrite it. Okay? So what we can do is we take whatever this variable is here in the middle. We don't really pay attention to the 6 yet. We create a new variable, let's say u, and we're going to set it equal to x squared. And then we rewrite the equation, and now you're going to see why they're like quadratic equations, because how do I get x to the 4 if u is x squared?
U squared.
Exactly. U squared minus 6, and then what was x squared? U plus 4 equals 0. Okay, so now we have an equation that looks like this first one, but now it's a quadratic. Okay, so how do we solve that?
Quadratic formula.
So the quadratic formula tells us that u is going to be what? So 6 plus or minus the square root of b squared, which is 36, minus 4, times a, which is 1, times c, which is 4, all over 2 times a, which is 1. So we get u is equal to 6 plus or minus the square root of 20 divided by 2. Let's reduce that as much as we can. So then u is going to be 6 plus or minus, what's the square root of 20? 2 root 5 divided by 2. We can divide everything by 2 here, so then we get u is 3 plus or minus 2 root 5. Or no.
Wait,
No. Good, you guys caught that too. Just root 5.
Yeah.
Okay, now, we've solved this equation, which told us what u was, right? But our ultimate goal was to find what? We want to find x. So now we know that since u is actually x squared, we can plug in x squared into u, set it equal to 3 plus or minus the square root of 5, and then now we can actually find out what x is. How do I solve for x? You square root both sides. Bless you. So then we get x equals, and then since I square rooted both sides, what do we have?
X equals square root 3 plus or minus.
Whenever you square root both sides of an equation,
Yeah,
plus or minus, right? The square root of 3 plus or minus the square root of 5. So it looks like there could be 4 answers here.
What?
Here's what we need to check. What can we not have inside of the square root?
Negative.
3 plus the square root of 5 is positive, right? What about 3 minus the square root of 5? Is it still positive?
Oh.
I think it is, right? Because square root of 5 is like 2 point something. So I want to confirm.
2.2.
Yeah. Okay, so both of these are okay. Sometimes you might have to get rid of the minus, depending on if it's a negative inside the radical or not. So here there's actually, you don't have to list them like this, but just so that you see there's 4 answers. You have positive root of 3 plus root 5, negative radical 3 plus root 5, and then you also have the negative versions of those. Those are all answers for this equation. Whoop. What did I do? That's not what I wanted to do. I wanted this to be positive, and then this to be, I'll just rewrite it. That's my bad, guys. 3 minus root 5, and then the negative of that. There we go. So these 4 answers are all solutions to the original quadratic equation, or quartic equation in this case. Okay, but the key here is to make it a quadratic and then solve like you would solve any other quadratic. Yes, Stephen?
We can keep it in the one before it, right?
Yes. This is fine. I'll take that. But I just wanted you to understand that this actually represents 4 different answers. Okay? Any questions on that example? Okay, let's try a different one. Let's say we have 2x to the 6th minus x to the 3rd minus 3 equals 0. Eric?
So you did the u thing again with this equation, right?
Yeah. What would you be?
Would it be x to the 3rd?
Yes. Very good. So then let's rewrite the equation. Instead of 2x to the 6th, now it's
It's 2u times 2u
2u squared. Very good. Minus u minus 3. And now you try to solve this the way you normally do. What do you guys want to do here?
Math.
You could do maths. I think it factors. I'll just do good old trial and error. 2u times u is the only way to get 2u squared. And let's see, 3 and 1 gets us to negative 3 if I make that negative and that positive. And if I check, does that work out? Yeah. 2u, this is negative 3u. Looks like everything works out. Okay. So then, what is u? U is possibly 3 halves, or 1.5. What's the other value? Negative 1. But again, we want x. So u is actually x cubed. So now we take x cubed and we set it equal to 3 halves. How do I solve for x? Cube root it. Very good. So then x will be the cube root of 3 over 2. And you can leave your answer like that. Yeah. Since we're done with the radical chapter, you can just leave it like this. Unless it's a square root, because that's on the AC, always with, but this is fine. So that's good for x when it's equal to 3 halves. And the other equation is x to the 3rd equals negative 1. Can we cube root negative 1?
No.
Yes.
Wait, I think okay.
Still negative.
It's just negative 1.
Oh yeah. Never mind.
If it's a square root or a 4th root, that's when you can't,
Okay.
right? So in this case, we have 2 answers. There they are. Okay? All right. Yes?
Will there be is there any? Can this get any harder? Because this seems kind of easy. Is there a crazy equation?
You want to see how crazy it gets?
Yes.
Don't put a lot of.
No? You just want to see it on the test for the first time?
No,
Okay.
no.
That's cool.
No, wait.
Are you recording?
I know. what
Yeah, I'm
you're
recording.
talking
Oh, yeah.
I see that paper.
But let's actually do the big problem.
Oh no, why do we use X code?
Why do we use x cubed? Because if we use x to the 6th, then it doesn't become quadratic because it's 2u minus u to the 1/2. We're trying to make this look.
I mean in the bottom when you did like X to the
Oh, right here?
Yeah.
Because up here, we said u was equal to x cubed. That was our substitution. So when we go here, that's what we set u equal to. Okay. All right. Let's try this one. X to the 4/3 plus 8x to the 2/3 plus 4 equals 0.
Is that the hard one?
I would say it's a little harder than the ones we've done. However, it's done the same way.
Oh.
You can make
Because what are we looking for this method with the quadratic types? We want this exponent to be what? Half of this leading exponent. Is it? Is 2/3 half of 4/3? Absolutely. So what's our substitution here? Let u equal x to the 2/3. See, now it's getting easier, right? Now we can cruise through this. So then what's the equation? U squared plus 8u plus 4 equals 0. I don't think this factors, so let's run the quadratic formula real quick to see where we're at.
Oh, shucks.
-8 plus or minus the square root of 64 minus 4 times a times c, so 1 times 4, all over 2a, so that's just 2. We get 48 in the radical?
Yes, sir.
So 48 is 4 root 3, right? Looks like everything's divisible by 2 again, so u is going to be -4 plus or minus 2 root 3. All right, so let's see what happens here. If this is u, now we replace u with x to the 2/3 equals -4 plus or minus 2 root 3. So now how do I solve something to the 2/3 power?
You make it a square root. The third root square. No? Exponent?
You could square root it, and then you'd have to cube it. Let's do it all in one step. Isn't square rooting and cubing the same thing as just doing the reciprocal power?
Yes, sir.
Right? Isn't that a little nicer? Right here.
There's still the U left over.
Why is that X?
Or there's the X left over from the U.
I hate fractions.
So then we do that to both sides. So then we get x equals. Now, when I square root, you guys understand that I'm really square rooting both sides here, right?
Sure.
Because the 2 denominator corresponds to a square root, right? What do you do when you have a square root on both sides? So it's possibly plus or minus all of this stuff to the 3/2. But now, we always want to check something. Since this represents a square root, what should we never have inside of the square root? All right, so let's see what happens. Use your calculators if you need to. -4 plus 2 root 3, is that a positive or a negative?
Negative.
Is it?
Negative.
I think it is negative. And certainly -4 minus 2 root 3 is going to be negative, right?
No solution.
So yes, this actually turns into no solution.
Wait.
Can't square root negative numbers. Well, you can, but we're not going to deal with it now. Okay? Yeah.
Will we ever get into like using eyes?
We will, but that's not for a while. We're going to spend a whole unit on that. Okay. So for now, if you get that, it's just going to be no solution.
Isn't there one where it's like I like you have to get like I equals 27 or something like that?
Yeah. Guys,
I didn't
you can touch each other later. Okay.
Well,
Yeah, Levitas was trying to touch me in the gym.
Are there any questions on that one? Okay, that's kind of the harder stuff in the section. I just want to cover the easy stuff too to make sure you guys are good. So that was quadratic types. The next examples are for problems like, I don't know, let's say 3x to the 5th power minus 19 equals 50, let's say.
Oh, this would be hard.
Is there a specific way of doing it?
Yes.
You factor out a 1.
Don't make it harder than it needs to be. How many x's do you see here?
5.
Well, technically yes, but how many places do you see an x?
What?
Can't you just get it alone? Yeah, just get it alone. 3x to the 5th equals 69 divided by 3. Wow. Sorry, YouTube world. My class is a little...
Wait, is it 23 special?
It is.
It's only Christmas.
In a good way, guys. In a good way.
You laughed at it.
Oh,
yeah,
So x to the 5th is 23.
I didn't know you were. I thought you got a rooting
It's
by
1.6.
5.
Answer is 1.6.
No, it's not. It's the 5th root
Mr. G, you're gonna be YouTube famous.
is the 5th root of 23. Oh,
Get a partnership.
maybe it's you guys that are going to be famous, not so much me.
We're being the craziest class ever.
Unless, guys, we've gone through this on quizzes and
That's
tests.
actually really easy.
Unless it says to round or use decimals, right, you really shouldn't. So, yeah, it's probably about 1.6, but we're going to leave it as the 5th root of 23. Okay? Do you guys see how to do these? Is this easy? Do we need more?
One more.
A lot more.
Okay, one more just for you.
Just for you, YouTube.
4x to the, let's say, 3, 4. Let's do 3 halves.
Well,
Minus
fractions, and then you might as well do
5
I should be hard.
equals
33.
No, I know. 64.
negative 1.
64. That's impossible. 4x to the
Actually,
3
it's
equals 4.
Yeah, I did. So what's the first step?
One.
Move
Is
to
this
5.
just
Add
one?
5.
Add 5, okay. Gotcha. So that becomes 4.
X equals 1. Oh, it is.
X to the 3. Careful, guys. Don't rush it. Divide by 4.
That's fine.
You get 1. How do I get rid of a 3 halves power?
2 times it by 2/3.
Raise it to the 2/3. Very good.
Okay. Well, the answer is close.
Saeed, go in the hall. 1 to the 2/3 is 1.
Yay!
Wait, how does 1
Because the cube root of 1 is 1. And then you square 1. You still get 1. In fact, 1 to any fraction or any power is going to be 1. Okay.
Bro, I got you.
All right.
Yeah?
Last skill in the section, then we're done.
You got a card?
Solving square root equations.
Solving square root equations. Fantastic. Oh, boy. My favorite.
The idea here is to isolate the radical first. Or if there's 2 of them, get at least 1 alone before you start squaring things. So, for example, We already went over one from the homework, right? Where you had a little square root and you had to move stuff around. Let's say you have square root of x minus 3 plus 9 hold on.
Hold up.
How do you look at
Hold up.
these? Do you like
Hold on,
solve
time
the
out.
problem in
3.
your head?
2x
Hold on, time out.
minus
You going 30 or full?
2x minus 3
30.
Let's see what happens with that. Okay, so we'll just go right to a problem that's hard, okay? Here we have two radicals. Before we square anything, we want to make sure at least one of the square roots is alone. Can we square? Is one of the radicals alone?
Yeah.
This one's alone, so if I square both sides, on the right side we get 2x minus 3. On the left-hand side, if it helps, write it down twice, because you have to be careful when you square this. Because when you square it, you're essentially going to FOIL,
Oh,
right?
yeah, true.
So what's root of x minus 3 times root of x minus 3? X minus 3. Good. And now we go root x minus 3 times 9. That's 9 of them. And then another 9 of them make 18 of those. And then we have 9 plus 9, which is, or 9 times 9, sorry, 81. And now let's combine some things here. We can move the x over. So it becomes just x. Negative 3 plus 81 is actually positive 78. Then we're going to subtract it. So that becomes negative 81 on the right-hand side. Okay. And because I want you guys to have more time in class to work on this stuff, we won't go through the whole process, but let's get to a point once where you kind of know what to do. Yeah.
Which 3? You ate it. Wait, which?
Oh, I guess you could have just canceled. That works too. Cancels out and then move the 81 over. Yep, Erica.
Did you solve the whole thing?
Not yet. Oh, okay. So you want to get rid of the square root somehow, right? Here's my advice. If you divide by 18 first, you get fractions, don't you? Let's avoid that. Because if I divide by 18, then I'm going to have to square stuff, and there's going to be fractions everywhere. I can square stuff right now. What do I get on the right? X squared 162x, and then 81 times 81. Someone help me out.
324.
What is it?
324.
324? 81 times 81 should be bigger.
Oh my god.
What is it?
6,561. Good.
6561?
Yes.
Okay. On the left-hand side, 18 squared, that's what you were talking about,
Yeah.
is 324.
Yeah.
And then we have x minus 3 still, because now the square root cancels.
Oh, that's all.
Yep. And then now you can just solve this like normal. Redistribute the 324. So what's 3 times 324? 972.
Yes.
And then you get this quadratic.
That's a very long equation.
And then now you just set it equal to 0. So 0 equals x squared. Subtract 324. That's going to be 486x.
Are we gonna have a problem with this?
Sure.
Wow.
This is insane.
And then now, someone help me out. 65, 61, we're adding 972 to it.
7,533.
Can we turn off the fan? It's so cold.
7,533. Okay. And then from here, it's quadratic formula.
Oh, fun.
Okay, which you guys know how to do. The point is, we needed to get to a point from here to an equation we know how to solve. Okay? Yes.
So eventually we're just finding out 2x.
Yes.
Wait.
And then at the end, when we get those two answers, we plug them both back into the very first.
The original one. And I would definitely store them. Because, you might have, like, radicals and stuff. So, like, type it in the calculator, store it into X, and then you just type this in, see what you get.
Okay.
Type that. It's a lot easier to check your answers that way. Okay.
No, you just